Hello everyone. In this tutorial video, I would like to explain how pressure is distributed in a fluid, including how factors such as density or depth change the pressure. A fluid, unlike a solid, has its molecules moving freely or flowing in all directions randomly. So this means it has a pressure throughout the whole fluid, because the molecules are pressing against each other not only within the fluid, but also against the walls of the container the fluid is in. So a fluid is different from a solid in that it exerts a force in all directions, whereas a solid exerts a force generally in only one direction. However, even though a fluid does exert a force throughout the whole thing, the force is not equal throughout the whole thing, it is different at different parts. The proof of this is that, since we know pressure equals force divided by area, and that gravity will act on a fluid just like it acts on solids, the pressure of the fluid equals the weight divided by the area. And we should remember that weight equals mass times acceleration due to gravity. However, a fluid does not have a simple mass like a solid, owing to the random motion of its molecules. But for liquids, like water, it does have a simple constant density. So we can remember the formula density equals mass divided by volume, and rearrange this to get the overall mass of the fluid equals its density times its volume. However, this only works with liquids because we remember that gases do not have a constant volume. We can next pay attention to the fact that by 3D geometry, the volume equals the cross-sectional area times the height. And we assume, to make our lives more convenient, that the cross-sectional area is the same regardless of height, which is true for many objects such as bathtubs. So now, the mass equals density times cross-sectional area times height, and the pressure equals density times cross-sectional area times height times gravitational acceleration divided by cross-sectional area, and cross-sectional area cancels out. So our final answer is pressure at a height equals the height times the density of a fluid times the gravitational acceleration. This explains why, when you are deep within a body of water, you feel a pressing force against you from all directions, as the pressure is greater the lower you go. Although gases do not have a constant volume and therefore do not have a constant density either, we can approximate this using an average density instead. And generally, owing to the fact that gravity exerts a weight on gases too, the air closer to the surface of the Earth is more dense than the air higher up, owing to the fact that there is more stuff, i.e. molecules of air, pushing down on it from above, compared to the air closer to outer space. Join me in the next tutorial video where I introduce you to the concept of Pascal's principle, which describes what happens to a fluid if an outside force or pressure is applied to it, as opposed to the internal pressures that were studied in this video. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.